Hi guys, and welcome to the third video of this mini series about geometry nodes and Blender. Today we're going to look behind the offset and position of the points on curves in geometry nodes. I hope this video will help you to solve some issues in your project. So let's get started. I hope you watched the previous video about rotation, alignment and scaling. If you didn't watch it, you can simply go to the link in the description or click in this video. Now I'm going to create a simple object or asset that you can use in your project to debug your position, scaling, and rotation in geometry nodes. And if you want to jump directly to the tip, you can just click on the next chapter, link in the description. Now I'm working with Blender 3.2.1 and we have to create this asset. So Shift A, go to Mesh, add a cube, tap to enter in edit mode, 3 to face selection, select one face, Shift to select the other faces, Alt E to extrude individual faces and not on the E to extrude, set 10, enter, tap to exit from the edit mode, go to material section, new material, set the name X. Go to R, G and B values to 1 for the red value, increase to 1 the roughness, add a new material, select X, duplicate it, set Y, set a value of 1 in green, add a new material, select Y, make a duplication, set Z, change the green to 0 and blue to 1. And there are our colors of axis. Now tap to enter in edit mode, Shift Z to see the back faces, or simply click this button to turn on and turn off this feature. Select the faces, select X, assign, select the faces on the Y axis, select the Y and assign, select the Z, assign, tap to exit from the edit mode, Shift Z to turn off the back face, and click this button to turn on the previous material. So this is the asset we want to use, and show the item information, scale it to 20 centimeters for example, Ctrl A to apply scale to obtain 1 in this section, select the scale, okay, this is 1, perfect, rename in axis and save the project. Now for this example, the tip 1 is the offset. So I want to create a simple Bezier curve. Go in the top part of the viewport and select plus, general and geometry nodes. Click the button new to create new geometry nodes. Turn on the material preview. Hide the axis. We can simply resample the curve, drag the resolution outside the geometry nodes, and to view the information, go to group section, select the count and rename in resolution, so I can adjust this value from outside this system. Now I can instance on the points of this curve what the axis, so I can drag the axis object in geometry nodes and link geometry to instance, and voila. Now you can imagine that I want to offset the position of these points before instancing. To do this, I have to set a new position of my points. So if you watched my previous videos, you have seen that I've used a particular technique to have a value from 0 to 1 distributed for each points on curve. So I use index, I use a mathematical operation, I divide the index by the resolution with a subtraction of 1, math, subtract 1, and if I divide the index by this value, I get a value from 0 to 1, 0 for the first point and 1 for the last point, even if I change the resolution. Okay, so if I link this to the scale, you have this result. Now you can get this same value with a free node from the spline parameter. This attribute called factor let us to have the same value of this. In fact, if I link this factor to the scale, the result doesn't change. Okay, so for now I move this a little bit. Next I will show you why. Now I have this factor. This factor is a number from 0 to 1, okay, distributed along the curve. So each point when it points has a factor value. So you have to imagine this graph. I want to transform this factor, okay, from 0 to 1 on my curve. I want to shift this curve in this side or the other side and have this result. So if I add a value to this, I move this line up. So the result is this. If I use a fraction, mathematical function, the fraction helps us to have always a value from 0 to 1. For example, 3.8, the fraction is 0.8. So in this case, I want this shifting. So from this point, when this value go over this boundary square, must restart from 0 and so on. So to do this effect, we have to apply a mathematical function to this factor. So I can use this value, I can add a parametric value that I want. This is the offset, okay, and I will use duplicate of this and apply a fraction. I can use this like a scale, and you can see if I add a value, you have the offset. Okay, I can increase the value and you can see the offsetting, but this is the offset of the scale. I want to offset the position, and now the points are not moving from the original position, but they have only a different scale but the same position on the curve. It's an optical illusion that they are moving through the curve. So now that we have this scaling factor, we have to recreate a new factor based on this offset. To do this, we have to add a sample curve, link the curve, and if I click this button factor, I can recreate a new factor distribute along the curve. So Blender assigns a new value of a factor on my points. So I can link this value and use this to control and set the new position of my points. Now if I move this value, okay, you can see correct shifting, but there is a problem. If I can show you in a better way this result, I will use a ping pong for the scaling. So math, I use this factor, I use the ping pong 0.5, it's perfect, and I use this multiply from the same value 0.5 to this, and here divide to always have a normalized value of ping pong. I described in a better way in my previous videos, so check it out if you didn't watch it. Now I use this for the scale, I use the ping pong to have okay multiple groups of scaling. I increase the resolution. Now if I offset the factor, we have this beautiful offsetting. There is a problem. This is a little issue. Blender recalculates the factor of each point and at the same time recalculates the value of the scaling. So I can use two methods for avoid this behavior. One is to use not the factor but this magical trick we have used in the other video. So if I link this value, now changing the value of ping pong, I can offset this value without any issue, because when I recreate the factor and go to the end of this workflow, in this point Blender use and calculate the scale, going back to this workflow and getting the new factor. Okay, this means that the point that goes from 1 to 0 has the scale changed from 1 to 0 as a value used in this ping pong effect. We don't want that. We want an initialization of a scaling of each point and then an offset of each point on the curve. So one technique is use this, so I have the index. The index never changed if you want. Or other technique is use the factor, but before sample curve, I hide the annotation, we have to capture or save or cache the scaling attribute in our geometry. So we have to save the float values of scale for each point on the curve inside the geometry and use the geometry with a new position. In this case, this is correct. So now I have to choose not this output, but this output saved as the scale. Now if I increase this value of offsetting, I will have the right result of shifting along the curve, maintaining the initial scale of each point. So you can choose whatever technique method you want to get this result. I will use the method of index, and I can Ctrl EX to delete this value. Now this is the first tip. Tip 1, offset. Tip 2, shift D to duplicate this geometry, Y to shift a little bit, we hide the first one. Tip 2, the bias. So imagine that you want to shrink this positioning in a range between 0 and 1 along the curve. So you can simply make it using always this factor. But before offsetting, we have to change the map range of this factor, okay, from a value as a midpoint and a shrinking parameter, okay, distribution parameter. So we would be a value from the midpoint up to a value up and the midpoint and a value down. So I can use a value 0.5, okay, the center of my curve from 0 to 1, 0.5 is in the center, and then add a mathematical function, subtract, and shift D to link this value, okay, and duplicate this value as a dispersion parameter. I can link this value up and down and use it as the minimum and the maximum of my bias, okay, before the offset. So I set the offset to 0, okay, I set the midpoint 0.5, okay, and the dispersion of 0.5. So the minimum will be 0 and the maximum will be 1, so the original value of the factor from 0 to 1. Now if I decrease the dispersion value, you can see all the position is shrinked. I can also move the offset of this bias along the curve and have another offsetting along the curve after the shrinking. So we can organize a little bit, adding a layout frame, bias, so I can drag this, I can move it a little bit, add another layout, rename offset position, drag this, I can use this, use shift right button and drag on these two curves to add a dot and link the value with this dot. Delete these two values, create another dot here and linked here. In the group section, this value is the bias point and the input is the shrink value. I can use this to shrink from what values? From min 0 to max 1, and the bias it can be from 0 to 1. I set 0 to the offset, the general offset. We can drag this into the general offset value, we can simply adjust a little bit the position of this field. And now I have three parameters: the offset, the bias along the curve, a sub-offset, and the shrink value. So you can make a weird effect if you want. And this is the second tip. Now the third tip I want to show you is offsetting instance by the scale that you apply on each point. So I duplicate these, Y to shift a little bit, hide the original, rename, offset by scale. So to show you in a better way this example, I will use a sphere. So this is a sphere, material, new material, okay, scale. Now I use this as a new geometry nodes. I will use this sphere as an instance. So I have to apply the scale of the sphere, Ctrl A sphere, and now turn off the offset, bias point the center, and shrink the base. So I don't want a large amount of ping pong. I can use a math multiply to make the sphere bigger. So you can see that the original curve is here. I want to shift the position in z-axis of this sphere by the scale multiplied by the size divided by 2 of each instance. To do this, we will use this offset socket in the set position. I have to multiply what? My scale, my final scale. So this sphere will be shifted a little bit, this sphere more, and this sphere more and more. I can use a math operation, multiply, but I have to have an information, the size of my object. Here you see the scale, but the scale is not the size of this object. So you can see the scale now is 1, 1, and 1. I want the real dimensions of this object. To have this, you can simply add a bounding box. The geometry can stay in, and now I have the min and max vector values. I can simply add a vector math when I can choose the distance from the max point and the min point of this box. If I can show you rapidly, this is not a lesson of mathematics, but you can see this is the bounding box. This is our object. This is the maximum value and minimum value. You can simply calculate the distance, divide by 2 to get the distance between the center of the sphere and one of these points. And because we have a three-dimensional object, we don't need to divide by square root of 2, but we have to divide by square root of 3 to get the correct radius of the sphere. So I can simply drag this, add a divide value by 2, divide by square root of 3. Now I can multiply this value with our scaling. Multiply, I can simply drag this value and use a combine XYZ to offset only the Z-axis, okay, leaving the other axis as is, and voila, this is the result. Okay, so now if I increase the scaling or decrease the scaling, we have one to go to front view. We have an offset based on the scale of our object. And if you play with the resolution or the bias and the shrink value, you can see correct offsetting without any issues. We can offset, we can decrease the ping pong to have multiple groups, decrease the scale, increase the resolution. This is our groups, and we can offset, shrink. This is the third tip For the final tip, I use a little help of geometry notes. This is valid for all these tips you've seen. You can jump in this and use a fantastic parameter called plot curve. You can add this and make your curve as you want. Before offsetting, you can make a shape of your vector parameter before offsetting. The same you can copy and paste to the bias and insert before the map range, so you can shrink and control your curve as you want. Thank you guys for watching this video. I hope you like it. If you want to, you can leave a comment, give a like, and if you subscribe to my channel, I would appreciate it. See you in the next video.